Thank you. All right. Hi, everybody. Thank you so much for coming to my talk today. So I'm going to tell you a little bit about Operation PROXYLIB, which is an Android malware that had overstayed its welcome on Android devices. So I'm Lindsay Kaye. I'm Vice President of Threat Intelligence at Human Security. My technical specialty and passion are reverse engineering and malware analysis. So the basic premise of Operation PROXYLIB was we identified a set of VPN applications, 28 of which are available on the Google Play Store that since have been taken down, that unbeknownst to the user, took your Android device, if you downloaded them, and then turned it into a node that was part of a residential proxy network. So the way that the threat actor made money off of this was they would sell access via something called ASOX, which is a residential proxy seller. So we named it Operation PROXYLIB primarily because the malicious library that was embedded in the malware was called PROXYLIB. So I'm going to get into how Operation PROXYLIB worked, but I'm going to give you a little bit of background in a couple of different things I'm going to be talking about. So first, I'm going to talk a little bit about ad fraud. So one of the things we do a lot is we look at ad fraud. And just to kind of give you an idea of what exactly that is very simply, it's when threat actors are trying to trick advertising platforms using something called IVT, which is invalid traffic. And you can see the technical definition there from TAG. It's that traffic does not meet certain ad serving quality or completeness criteria, or otherwise does not represent legitimate ad traffic that should be included in measurement counts. So if you're reading this and asking yourself what exactly that means, I have a couple of different examples that should help clarify it. So here's a couple of different examples of what ad fraud can look like from the app perspective. So first, out of context ads. So these are ads that are outside of the app's normal container. And what that looks like, you have a couple of examples there. So on the left, you have a fake lock screen. So you can't tell where this ad is coming from. It's not associated with necessarily any app. And on the right, what you can see is you have an inactive screen that pops up a web view containing an ad. So next, you have something called false representation. So simply, it's when you have a request for some sort of ad inventory that's different from what is actually being supplied. So kind of an easy way to think about this is if you have an emulator that's masquerading as a device, obviously people who are pretending to be a real device, you're not intending to show your ad to an emulator, so false representation there. Then misleading user interface. So this is something that where you're rendering ads that aren't visible to the user. So a couple of different techniques they'll use are stacked ads, clickjacking, and pop-unders. So what stacked ads are is you'll see as a user one ad, but they may be saying they have several different ads stacked on top of each other, the rest of which you can't see. Also fraudulent. And then finally, undisclosed use of incentives. I think this is probably the one that we're all most familiar with. So really, it's any sort of use of financial or other incentive that makes the user have to interact with one or more ads. So for example, if you have some kind of app that says if you click on this, you'll get some sort of extra points or money or something like that, also bad. So the next kind of topic that I'll talk about is residential proxies. So what this is you have a network of real residential IP addresses that belong to these real devices, and you can route. So generally a lot of threat actors will route their traffic through these because they want to hide their IP. So they want to make it look like they're coming from one of these IPs, not their own. So how this can work. So you have a pool of residential IPs that are available. Somebody might purchase access to this proxy service. So at that point, the user will make some sort of web request. So for example, they might visit a website. Goes to the proxy server picks from that pool of residential IPs. The request comes out the other side to the internet, looking like it was coming from that residential IP, not the threat actor. So these can be used maliciously, should not be surprising, in a couple different ways. So first, sometimes people will conduct their own cyber attacks using them. So generally from a lot of the data that we see, we see things like account takeovers, credential stuffing, web scraping, transaction abuse, advertising fraud, and several other types of things. So these are just a couple of the examples of ways that threat actors can abuse them. Next, if you own the residential proxy network, so you're on kind of the other side of the coin, you can sell access to other bad guys who want to do any of the above. So kind of a different model there. So how are residential proxies and ad fraud related? So pretty similar, somewhat different from those general use cases. So a couple specific ones. So geo-restricted ads. So sometimes certain ads are only shown to people in certain geographies, right? You're probably pretty familiar with different sort of demographics of trying to display ads. And if, for example, a threat actor has a really vested interest in getting a lot of views or clicks on ads from a particular geography that they are not in, you could do something like use the residential proxy IP to pretend you are. And kind of similarly, also a lot of different types of spoofing attacks, but to name a few. For example, if you want to pretend to be a specific type of device or person. So, for example, if you are not a real person, you are an emulator and want to pretend to be a person, using a residential IP offers a good option there. Or if they only show certain ads to certain types of devices, that's kind of another thing that you can use this residential IP for. Also, trying to hide the request is coming from a server. Generally, when people pay to show ads, they want to be showing them to actual real-life people. They don't want to be showing them to emulators because they're paying for nothing. So this might be another opportunity for threat actors here. So why do they use them? So generally, when you look at what IPs are on block lists, you don't tend to see residential IPs. Obviously, if you think about if somebody's blocking IPs that belong to people, customers are going to start getting pretty upset. So generally, these are not on those block lists. And kind of another detail is that as defenders, when we try to detect and block malicious behavior coming from these residential IPs versus data center IPs, it's a lot harder. So you can imagine, again, how you don't want to block, your typical users or your customers from accessing your services when you're trying to kind of root out malware and block it there. So it's a little bit more challenging to do so. And then finally, the legality of actually using them is somewhat murky, though I will say that generally, when you use those residential proxy services, the sourcing of the IPs is somewhat more questionable, and people are really not forthcoming, not surprisingly, of where they are getting sort of their inventory of IPs. And they're not a new threat. So this is something that has perpetuated for a while now. You can see a couple of different examples there, and they are definitely hard to protect against and pretty persistent. So when we looked at something called Bad Box, which involved backdoored Android CTV devices and kind of lower end phones, there was a residential proxy module that was downloaded as part of it. So many different threat actors in this space, and it's not something that I picture going away anytime soon. So now I'm going to get into the technical overview of kind of the first part of PROXYLIB. So, like many other researchers in this industry, what we generally try to do is look at other sort of industry publications, often related to things like ad fraud and bot threats, because ultimately we want to be aware of anything coming out that might harm our customers. So we saw this report where other researchers identified an app called OkoVPN. So this Android app was in the Play Store, and they mentioned that they saw it associated with some kind of ad fraud. Okay, interesting to us. That's something that we obviously want to protect our customers against. But what they noted is that somehow, they didn't really specify how, it took the user's device and enrolled it as a proxy node in a residential proxy network. So that was particularly interesting. They didn't really say a whole lot about how that worked, and they more focused on kind of the threat from the ad fraud there. And they noted that the app was removed from the Google Play Store in March 2023. And I believe at the time of publication, it had over 1 million downloads. That's a lot of downloads. So how did it work? So one of the things we wanted to do is we wanted to take it apart and verify kind of how it worked and kind of get an understanding there. So as you can see, you have OkoVPN, the app, and then what it does is the user can see they have a normal app behavior. You get a free VPN. So that's what the user interface looks like. You click the VPN, you're off to the races, or so you think. But in the background, what it is doing is has a native library called libgojni.so that is taking the device and then adding it as the node in the proxy network. So with this understanding, I'll tell you a little bit about specifically how this app worked to kind of give you that technical understanding. And what I want to underscore is it really wasn't complicated, to be honest, how some of that malicious functionality worked, which is kind of interesting. So one way that Android malware can persist is using a combination of two different permissions, foreground service and boot completed. So this means that it won't be killed by the system or battery saver. So if it goes to the background, it can't be killed. And it will start back up at boot time. So your device goes off, it comes back up. So when you're thinking about a VPN application, not necessarily something that you want always on or to start up at boot time. So a little suspicious there of why it's kind of behaving this way, but we'll keep going on. So looking at the Android manifest, which essentially functions as the recipe and kind of rule book for how the Android app works and what it does, you can see these permissions right there. And you see a couple other more, VPN appropriate permissions. So things that you would probably expect a VPN app to use. So then diving deeper into it, we wanted to understand exactly what it does when it kind of reboots. So you see this service, YF start receiver, that is executed at the boot of the device. Okay, let's dig in more to that. So this receiver very simply starts something called the app service class as a service, starts the proxy functionality in a thread, and then calls the embedded Golang code to start the proxy service on the device. So this is not a wildly complicated piece of Android malware, if you've had the opportunity to look at it, right? So pretty interesting, and they explicitly call it PROXYLIB. So if you're looking at the code, you might be wondering, why is there proxy code in my Android app that's not supposed to offer a proxy? So this is what the Golang code looks like. So I know a couple other of the speakers talked about it, but basically there's different types of native code sometimes incorporated with Android apps. So it's not just Java. C and C++ were pretty popular, but now you see a lot of Golang. Nice thing about Golang is cross-compilable. It's a little bit harder to reverse engineer, but now there's a lot of tools out there to help. But this is simply what the Golang looked like. So again, not obfuscated really in any way, and pretty explicitly easy to understand what's going on. Very simply, what this code does is it'll maintain a connection with the command and control server, and it has some kind of heartbeat to it. So this distinctive ping-pong communication that you see here, these messages back and forth, was something that we kind of considered a hallmark of PROXYLIB. So I know other tools out there do this, but that in combination with some of how the C2 messages were encoded really helped us sort of eke out what is part of PROXYLIB and not for this initial stage. So now you have your device enrolled in the proxy network. And what you can do is you can sit there and watch it relay web requests. So it works like really any other proxy. So here's a couple examples of what the traffic looked like. So we were not visiting Instagram, we were not visiting Facebook, but somebody else was. So using our device as the proxy, unbeknownst to us as the user. So now what? Clearly we have something not good happening here. So we looked for other ones because if there's one, oftentimes there are more. So in this first round of what we called PROXYLIB version 1, we found 14 applications available in the Play Store. Largely, these were free VPN apps, mostly. I think there were a couple other ones as well. But what we did was we flagged them to be taken down. And this, obviously, is where the story and this talk will end. Nope, that unfortunately was not true. So, PROXYLIB v2. So at this point, we had gotten those apps taken down and kind of had some signatures for PROXYLIB v1. Obviously, this was something we continued to monitor because it was of interest to us to see how it evolved. Sometime around May 2023, we started seeing a little bit of chatter on hacker forums and then looking in some VPN applications that were available, talking about something that was a monetization SDK called lumiapps.io. So monetization SDKs very simply are if you want to make money from an app you have developed, you can use this SDK and the money starts coming in as you get users. So they're very explicit about not having an ad-based monetization model, but they are very kind of vague and kind of cagey a little bit about how exactly they are making the money for you as the developer. And I would like to draw your attention to this, upload and download SDK or download APK to share with your friends for the next slide. So there's two options for how you, as an interested party, can use the LumiApps platform. So first, like any normal SDK, you can implement it in your Android app if you would like to. It's pretty simple. We'll look at that soon. But also, you can upload any APK to the site without having the source code for it because you want to add the SDK to it. So you drag it, you drop it, you might find an APK kind of sitting around or, any famous APK you might know. Then you can download it and there's the button to share it with your friends because that's what you should do with your malware. So this, generally, what we saw these look like, they were mostly mods of legitimate ads. So they were of legitimate applications. So none of these were actually in the Play Store. I don't think they would make it in. They would not be approved. And they were available outside. So it was more kind of finding them on third-party sites, things like VirusTotal, just kind of laying around there. However, we did see multiple developers actually integrate the SDK and develop it via the Play Store. So here's an example there of what it looks like. So you can see not using kind of that free VPN model. This is something called phone comparison, whatever that means. So from kind of the developer perspective, one of the things that Lumi Apps has is kind of nice, thorough documentation. So if they're really kind of trying to go for that legitimate SDK to get people to use it. So you can see the documentation here of how easy it is to add this to your app. So you just include the App Pro library and then add 3 main classes. So App Pro Service, App Pro Receiver, and App Pro Worker. So when you start to take the app apart, so you reverse engineer the app to see what exactly this had for impact, this is what you see. So your App Pro Service is really where that PROXYLIB server is started. Then you get your URL for the C2. And then finally, again, it calls that same PROXYLIB start server Golang code, which really hadn't changed between the different versions. So again, pretty simple, no obfuscation there. Developer obviously is not super aware unless they have reverse engineered their app. This is what's going on behind the scenes. So you may be asking yourself, this is great and nice and all, but how exactly is whoever is doing this making money? Because generally, cyber criminals are out to make money. So as I mentioned, there are 2 key ways that I've identified to make money with respect to residential proxies that we saw in this campaign. So first, you can conduct attacks on your own, or on the other side of it, you can sell access to your residential proxy network. So in comes something called ASOX. So ASOX advertises itself as the most stable residential proxy network. You can see, pretty professional looking site, and they sell this universal proxy service for $3 for 1 gigabyte. So if you think a couple YouTube videos, you've already blown through the 1 gig. So this is not a cheap service to necessarily go use that you can, as regular device users, we should just go replace all of our, normal device use with. It is somewhat pricey for what you're getting. So I will tell you more about it. So you can see their terms of service. Again, they're sort of trying to make this legitimate and sort of a stand-up thing and talk about, all their rules. But really, you don't see anything there that's super distinctive. I think, in fact, they're just defining what a proxy service is. So that's kind of interesting. They are pretty explicit about advertising themselves as the seller of residential proxies. But like most residential proxy services, they aren't explaining where the traffic that they sell come from. So not explicit there, not saying, where they source it or anything, but that's not surprising. And the way that we started to kind of become interested in ASOX was we saw some of our test devices that we were running these apps on connecting to asox.com. We're like, I wonder what that is. So when you subscribe to the ASOX service, one of the things that you can do as a user is create and manage your own exit points. So where do you want to be coming out of? And you have a wide variety of choices here. However, I will note that the availability of residential exit points does vary significantly by country. So you can see, obviously, there's some countries with significantly more inventory than others. So you kind of have to pick and choose, maybe wait around for a bit. If there's one that's interesting to you, there's not a lot available. So this is well and good, but a couple connections from a device to this asox.com, not really enough of a smoking gun here. So decided to dig deeper. So in order to use Lumi Apps as a developer or anything like that, you have to subscribe to it or kind of make an account. So when you make an account, get an email back. And then if you look in the email headers, pretty interesting, you receive them from mail.broxy.1. So this is interesting. This is different. So I wonder what that is. So taking Broxy.1, putting it into the Wayback Machine, one of the things you see is you can see what looks like some old kind of copywriting for ASOX. So that's pretty interesting. But again, this is somewhat circumstantial, somewhat OSINT-y. We needed a little more proof here. So we want to know, is ASOX in fact our guy? Are they the ones that are monetizing this residential proxy app PROXYLIB campaign? So we ran an experiment because we want to do some science. So if in fact the device IPs were being sold via ASOX, you would expect to be able to take your machine, join ASOX, the residential proxy network, and then be able to see your traffic come out a device that is in part of this network. So we set up exactly that. So you can see, we put a device, joined it to the ASOX proxy network, took our Android test device, installed one of these apps, and then made sure it was now a proxy node. So one of the things we did is we grabbed our IP address on the phone. Then grabbed, there's a curl command that you can run via ASOX to see what your IP is, just to make sure you're coming out of where you think you are. So at that point, we were able to rig it such that we were able to confirm that our IP was the same as that of our phone. And then when we make a request, it was going out to the internet as if it was coming through our phone. So that was pretty good proof that this is what was happening there. So now we have a much more full picture of how PROXYLIB works, rather than just at the beginning where we just had OcoVPN. So we have a wide variety of these bad VPN and other types of apps. Again, you have your normal app behavior, your VPN for your user, but now, in addition to having that residential proxy node edition native library in the back, what you see now is that you're coming out of ASOX, and that's how threat actors are monetizing it, and other people can buy access to it for whatever they like. So it's really important now that if we want to make some good money off of this, we got to get people to use it. And the way that we do this is, so one thing I want to point out about Lumi Apps is that because it needs to attract developers to its platform, because they want to be able to sell their IPs via ASOX, they need as many proxy nodes as possible, obviously. One of the things that they do is they really do attempt to very much legitimize their service and make it look professional and quality, because they want people to use it, both good and bad people. So one of the things you can see here is that they have a couple different words. So the GDPR and CCPS compliance, they say only by consent. So they're really trying to make themselves look like a legitimate business. You can see, I think some of their copy has changed if you choose to kind of go look at lumiapps.io, but this is kind of an interesting point because they really are trying to seem like they're behaving above board. When they say it's only by consent, so they technically do claim to render a user consent screen when you use the SDK for your integration, and the code does exist, but when we looked at the majority of apps, they actually didn't display this consent screen. So when you kind of look at this, this is the code, this is what it would look like. We didn't see this in the vast majority of apps, including the ones where you take the APK and upload it to their site, because that by default adds the SDK without any user involvement. So you would expect it to display this, but it didn't. So it's there, but didn't seem to use it at that time. Another thing that they did was they really advertised Lumi Apps SDK in a couple of places. So both on things like social media. So here's a couple of examples of from LinkedIn. So they have a LinkedIn page, really seems like a fine, upstanding SDK that anybody would want to use. But they're also kind of at the same time advertising it on hacker forums. So they really kind of do seem to know who they are targeting and who are their ultimate customers for using this SDK. Because, if you're a developer and you're starting to ask questions about, okay, I'm using this SDK, but where's the money coming from? You want to feel good about it, right? But yeah, I guess they understand that hackers probably just don't care. And their service actually did enjoy victory. So largely due to their marketing and kind of the prevalence of some of their traffic. At its peak, we saw an estimated 190,000 nodes in the ASOX residential proxy network. So it's important to note that we don't know every single source of the IPs that residential or the ASOX was getting. We do know PROXYLIB apps were one of them, but they may have traffic somewhere else. So not all 190,000 nodes are PROXYLIB apps necessarily. And then when we did some tests, because we wanted to see okay, well, if we join this, if we just leave our device on, how much traffic goes through it? We saw 5 gigabytes of data transferred in a few hours. Yep, really 5 gigabytes. That's a lot through one device. And if you have a data plan that's unlimited and you think about it, you might have 2 gigs a month. That's it would blow through that data plan in just, a couple hours there. And the user would have no idea why. They would have installed this app and then just have no clue, because it's not like you're, surfing the web a lot or watching a lot of YouTube videos on your cell plan. You have no clue what's going on here. So what we wanted to understand is okay, great. Now we've seen all this traffic coming through the device, but what are people using this proxy network for? Maybe it could be legitimate, benign uses, or maybe it could be threat actors, but we wanted to have some sort of scientific answer here. So looking at the majority of these contacted domains, they were known bad. So things like C2s, any sort of malicious downloading, different things there. So hard to know what they all were, because didn't check them all, but that seemed to be kind of the trend there. Looking at some of those user agents, most of them had headless Chrome. So if you are a legitimate user, you're user agent doesn't have headless Chrome. This is something that a lot of bots will do. They will run headless from these browsers, so you get that headless Chrome browser there. And we saw evidence of obvious crawling, scraping, and brute forcing activity when looking at this data. So to sum up what was going on with the data that was proxying through our device, nothing good is happening, and it's happening in very high volumes. So clearly, their customers were enjoying some kind of victory. So looking at a lot of our kind of bot traffic data, what we want to understand is, okay, well, great. They are doing bad things, but what kinds of specific bad things that we should be making sure we protect our customers from? So the majority of the traffic was account takeover, scraping, and scalping attacks. So none of that is good. So yes, when you kind of look at this is a pretty bad situation for people who have these apps and people who are being victimized by the ASOC's residential proxy IPs and suffering from a cyber attack. So we had to do something about this. So first, we knew that we could do something about these Play Store apps like we did before. So what we did, notified Google, and all of these apps were taken down. So additionally, we provided different insight and detections to some of our partners to make sure that they knew how to identify them, so that if other versions of this kind of went in, that would be something that would be kicked out of the Play Store before it caused a problem. Now you ask yourself about those other apps that are available via those third-party sites or sent between friends or something like that. There's no direct action we can necessarily take to make sure somebody doesn't download it, because if you want to sideload an app on your Android device, you can probably do that. So I guess one great piece of advice that we always kind of talk about here from the app perspective is don't download things that are called mods or sideload apps in general. Obviously it could go fine, but in general, you don't necessarily know what you're putting on your device, so I would totally avoid it. However, Google Play Protect can help. So this is something that's on by default on Android devices with Google Play services. Recommend leaving it on. And what it'll do is it'll warn users or block any of these apps that are known to exhibit these malicious behavior. So even if they come from sources outside Play. So again, providing a lot of our detections and insights would make something like Google Play Protect catch these malicious apps, even if they're from outside of the Play Store. So you may be asking yourself, okay, but where does the ad fraud that we talked about in the beginning kind of come in here? So as I mentioned, the original OKO VPN app, the researchers who took it apart and kind of initially surfaced the lead, noted that it was used in conducting ad fraud. So we didn't actually evaluate. So when we evaluated the residential proxy IPs, we didn't find evidence of widespread ad fraud in our data. So it's really hard to say why exactly this is. Obviously, the use of ASOCs is largely dependent on the customers of ASOCs and what they're doing at that time. And when we looked at the data, we didn't see any ad fraud. We saw those other types of attacks mostly. So at this point, we have to be done, right? We are not. Lumi Apps has continued to evolve and does to this day. But I'll talk about a couple of the first sets of evolutions here. So it's very clearly under development by its authors even today. The new versions of the malicious code started popping up sometime, I believe, around October. We started noticing some of these changes, indicating that they were kind of upping their game. So kind of a good indication that the threat actor's trying a little bit harder, because they have to, is when they start adding things like obfuscation, which we'll look at on the next slide. They took the native library and they renamed it because maybe PROXYLIB was too suspicious. Maybe that's how we were catching them. Rename it to something else. They have a new command and control scheme, so a little bit more complex there. And they have a new technique for how they keep the foreground process active, so making sure that it's not killed by system or battery saver. So none of these were super sophisticated additions, but they do definitely demonstrate that the threat actor is in fact evolving their techniques. So first, what this obfuscation looked like. So in the first versions, the strings in the Java code were not obfuscated in any way. So sometime around or before October 2023, they started with string obfuscation. So you can see on the left, your left, some of the source code from the Lumi Apps built app. So this is just in JADX. It looks pretty good, cleaned up pretty well. And then what you can see is something called the source code of LS Paranoid. So obviously pretty similar. It was able to be, you can use the same sort of deobfuscation techniques that you would use for LS Paranoid. So pretty sure it is in fact that. So this isn't something custom built. So yes, it is a little more sophisticated, but not as much as if they had custom built it. And then just general other kind of refactoring and new TTPs. So some light refactoring of some of the key library functions. So they changed app pro service to app service to start the PROXYLIB server. They changed app pro receiver to app receiver to start the service. So just light refactoring there. Now, to do any of the decryption of the CGU communication, what they did was they gathered key materials from different, openly accessible sites that are sometimes victimized by malware. So things like GitHub and Dropbox are a couple examples there. And that's where it reaches out, pulls down the IV and key material that it uses. And then the technique that I thought was pretty interesting of how they were persisting the malware and making sure it kind of kept its foreground capability was they had a silent MP3 that they just continuously played on loop. So kind of a new interesting technique for them to be using, kind of an interesting addition there. And another thing that we noted is it's not just Android. There was a Windows version too. So you can see on OcoVPN's official website, they still have their Windows installer. So while the apps have been taken out of the Android store, or the Google Play Store, the Windows one is still there, and at the time of analysis, I noticed that it still had the same residential proxy functionality. So that's still out there, that's still available, and it still is using that PROXYLIB DLL name. So they haven't made some of the same adaptations and additions to the Windows version that they did on the Android version. So you can see the very characteristic ping pong for that Windows version there. So if you're looking at what this means, it's very likely that the threat actors are actually reacting to the detections implemented by defenders. So we really are having an impact on them, and we're making them up their game. They notice that they're being kicked out of the Play Store, where potentially they're getting a lot of their users and a lot of their downloads from, and their apps are likely getting flagged as malicious. So not only from the Play Store, but if you're using Google Play Protect, those are probably being flagged and deleted as well. And Windows presents them a whole new opportunity. To date, we haven't really seen them take much advantage of that. However, if you are using your computer and your computer is now node in a residential proxy network, unless you're really monitoring your traffic, it's likely a lot more difficult to notice that there's additional traffic that you're now proxy node in this residential proxy network versus something like your mobile device where it's like, oh my God, now I've gotten 10 gigabytes of traffic in one day. What is happening? And this is substantially more difficult to take down versus something like an app. If you kick an app out of the App Store, obviously it is no longer available there. But as we all know, things like Windows malware are persistent and successful and a complicated issue. So what this means is the story isn't over yet. This is an ongoing investigation that to this day we are still following and seeing how they evolve. So now what? We, obviously want to stop PROXYLIB, and we need to figure out how. So at Human, we are continuing to monitor how these TTPs change. So we keep our detection rules updated. We implement new ones, kind of follow and see what they're doing now as they have changed their TTPs. Also involves looking for new ways of monetization. So cyber criminals looking to make money. If you cut off different avenues that they have to make money, they will find new ones, generally because they want to keep doing so, and this is lucrative. We look for new infrastructure that could be associated with this and try to find connections to other malware. So sometimes what you'll see is threat actors will have several different irons in the fire. So it won't be just this type of malware. They may be associated with other things. So we're trying to understand sort of how that works as well and monitor it as well. And we try to make it more difficult for them to make money. So that's a great thing if you're trying to thwart a cyber criminal. So anytime we see new apps, we make sure that they are removed and obviously keep providing detections there. So making sure the detection methodology is available to external partners with the ability to help make sure that these actors get kicked out of the App Store, and do anything we can to make them rebrand and retool and try a little bit harder because it wastes their time and they have to keep trying in order to keep being successful. So when you look at residential proxies, they are not going away. So like many things, threat actors will continue to use them while they are still useful. And in this day and age, they're still useful. So they still make it a lot harder for us as defenders to detect, as I mentioned. So threat actors will likely keep going after them. But we, as defenders, can do a couple different things. So looking for different ways to make it more expensive for attackers. So obviously residential proxy services aren't cheap. If we keep getting better at detecting them, potentially there's some cost benefit to us and, cost detriment to them. improving our own ability to block these attacks. So as we get better at blocking things like residential proxy attacks, these services become less useful to them. They have to find other avenues there. And when you're looking to, use things like SDKs or tools or different types of services, definitely being more aware of what we are buying or using. So as we can see, things like free isn't necessarily free. Like as they say, there's no free lunch. So if something's offering, a free VPN, kind of ask yourself the question of what exactly could they be monetizing there and what exactly is the product. And often we talk about like having different sort of layers of security. So being able to double down on the rest of your non-network security strategy. So things like behavioral and AV are a couple examples, and authentication and password. So like I mentioned, a lot of what we saw these residential proxy IPs being used for were ATO, credential stuffing, scalping, and scraping. So things like authentication and password can certainly be improved there. And with that, thank you so much, and I'll take any questions.
So going back to the criminal point of this, if users openly consent this, would you call this still criminal, or should Google still take it down? If openly users, consumers say, yes, use my device, I don't want payment, but I like the free VPN service and you could use my internet. So would you still call them criminals?
So that's a really hard question. So at that point, it would be a question of if Google could take them down, if they've consented to this. Generally, though, what we see from cyber criminals is they'll have that consent, but they won't explicitly say what it is. Like they'll have these like sort of vague things. Like I believe Lumi Apps had something about consenting to like your device being used for like research university data or something like that. So it would be kind of more of a legal question of like, well, what is the user consenting to? Is that enforceable? Different things like that. But that's a great question.
Thank you for this great presentation. Do you know if you can access local network over this kind of proxy?
So I believe that you can. We didn't really look into that, and that wasn't something we really focused on. We were more focused on, because of like sort of what we do is the ATO and the ad fraud and different thing aspect of it. But yeah, I believe you can. So that's unfortunate.
So out of curiosity, if I'm the threat actor, you mentioned that the price per gigabyte is about $3, right? Mm-hmm. So have you checked, or do you know what the developers actually earn if they implement it? Like what's the company's margin?
So if I was a Lumi Apps developer and
if you were a developer and you wanted to make money,
and I
by integrating the SDK into your own application, so how much would you earn per gigabyte of shared data?
So I don't believe we checked into that. It would be a little bit difficult because I, as a developer, wouldn't necessarily know how many gigabytes of data my app was getting shared through necessarily. And to do that, we would have to do that. And I don't think we could.
Yeah, so. True. Thank you.
Okay. Well, thank you all.
Questions?
Oh, no more? Okay.
Thank you, Lindsay.
Sure. Thank you so much.